In this question, we're imagining that someone is doing an experiment with four conditions. One group is studying 0 hours for an exam and sleeping 2 hours on the night before the exam. One group is studying 10 hours for an exam and sleeping 2 hours on the night before the exam. One group is studying 0 hours for an exam and sleeping 6 hours on the night before the exam. And one group is studying 10 hours for an exam and sleeping 6 hours on the night before the exam. In this question, you need to look over these two results and decide which one you think would appear if the experiment was done. If you think that result A would appear, circle A. If you think that result B would appear, circle B. If you think that neither result would appear, circle C. In outcome A, the people who are studying 10 hours are doing better on average than the people who aren't studying. The people who are sleeping 6 hours are doing better on average than the people who are only sleeping 2 hours. And the two sleep groups are benefiting the same amount from studying. The 2-hour group and the 6-hour group are improving the same amount when they study 10 hours for the exam, which is why the lines are parallel. So if you think that the two sleep groups would benefit equally from studying, you would choose A. In outcome B, once again, the group that's studying is doing better on average. The group that's getting a full night's sleep is doing better on average. But the group that's sleeping 6 hours is benefiting more from studying, and the group that's only sleeping 2 hours is benefiting less from studying, which is why the two lines aren't parallel. So if you think that A would appear, circle A. If you think B would appear, circle B. If you think that neither would appear, circle C. In the next question, we're once again imagining that an experiment is being done with four groups. One group is studying 10 hours for the exam with distractions in their study environment. One group is studying 10 hours with no distractions in their study environment. One group is studying 20 hours with distractions in their study environment. And one group is studying 20 hours with no distractions in their study environment. The experiment has all four combinations, and one group is experiencing each combination. And once again, you need to look over these results and decide if you think A would appear or B would appear if the experiment was done. And if you think that neither would appear, circle C. The two main effects graphs are the same in both choices, so we just need to focus on these last two graphs right here. If you think that the distracted study group and the non-distracted study group would improve the same amount by going from 10 to 20 hours of studying, you would choose A. If you think that the group that's studying without distractions would benefit more by going from 10 to 20 hours of studying, and the group that's studying with distractions would benefit less by going from 10 to 20 hours of studying, you would choose B. So in choice A, the two groups are benefiting equally from extra studying. In choice B, the group that's studying without distractions is benefiting more from doing extra studying, and the group that's studying with distractions is benefiting less from extra studying. If you think that neither result would appear, circle C. This is another experiment with four groups. We have one group that's studying for, we have one group taking an easy exam with 30 minutes available to take the exam. One group taking a difficult exam with 30 minutes to take the exam. One group taking an easy exam with a full hour to complete the exam. And one group taking a difficult exam with a full hour to complete the exam. So we have everyone in column 1 is taking an easy exam. Everyone in column 2 is taking a difficult exam. Everyone in row 1 is time pressured. Everyone in row 2 isn't time pressured. If you think that the group that has a full hour to take the exam would do equally well on the easy and difficult versions, and the time pressured group would do better on the easy exam and worse on the difficult exam, you would choose A. If you think that the time-pressured group and the non-time-pressured group would both do more poorly on the difficult exam, but it would just be a more dramatic difference for the time-pressured group. You would choose B. And if you think that neither result would appear, circle C. Here we have another experiment. Everyone in column 1 is taking an open book exam. Everyone in column B is taking a closed book exam. Everyone in row 1 is studying by memorizing information. Everyone in row 2 is studying by creating a set of notes or compiling a set of notes. So you need to choose which outcome you think would appear. If you think that on the open book exam, the note takers would do really well and the memorizers would do really poor, and if you think that on the closed book exam, the memorizers would do really well and the note takers would do really poor, the opposite result, you would choose A. If you think that the note takers and memorizers would both have medium performance on the closed book exam, and if you think that on the open book exam, the note takers would do really well and the memorizers would do really poorly, like this, you would choose this other choice, which should say B. If you think that neither would appear, circle C. And this is the discussion questions. The first one says, do you think that the idea of an interaction is well captured by the phrase, it depends? We talked about how an interaction is when the effect of something on something else. We talked about how an interaction is when the effect of A on B depends on C. So the effect of alcohol on intoxication depends on food intake. That's an interaction. The effect of hours in the sun on sunburn depends on whether sunscreen is being used. That's an interaction. So here I'm just asking you, do you think that the idea of an interaction is captured concisely by the phrase, it depends? If you think, so answer yes or no and explain why or why not. Question 2 says to explain why the video in the experiment was a 2x2 factorial design. In class a few days ago, we watched a video in which there was 4 scenarios in the experiment. The video was showing an experiment with 4 scenarios. There were 2 types of crime, a robbery and a swindle, and there were 2 types of attractiveness, an attractive criminal and an ordinary looking criminal. And the dependent variable was the sentence that the participant would assign to the criminal in this scenario. So you need to explain why it's a 2x2 factorial design. Remember that in the experiment there was 2 types of crimes and 2 levels of attractiveness. Also, explain why the result was showing an interaction. I can show the link to the video to show you what the results look like. In the outcome that was showed in the video, the effect that the attractiveness had on the sentence depended on the type of crime. So when it was a robbery, the attractive person got a lighter sentence. When it was a swindle, the attractive person got the harsher sentence. This third question says to assign 2 different shows to time slots so that neither show has a disadvantage in ratings overall across the entire season. So I say to put a 1 or a 2 in each box. So if you put a 1 right here and a 2 right here, that means that show 1 is at 9 p.m., show 2 is at 11 p.m. If you do the opposite and you put a 2 here and a 1 here, it means that show 2 is shown at 9 a.m. and show 1 is shown at 11 p.m. In each week, you need to during each individual week, you need to assign the 2 shows to time slots. So if you put a 1 here and a 2 here, that means that during week 1, the first show is at 9 p.m. and the second show is at 11 p.m. If you flip it around in week 2 and put a 2 here and a 1 here, it means that the shows are reversed, and show 2 is at 9 p.m. and show 1 is at 11 p.m. So I'm asking you to try to do this in a way so that neither show has a disadvantage in the ratings over across the entire season. This next question says to take 3 shows, show 1, show 2, and show 3, and assign them to time slots so that neither show has a disadvantage in ratings. So in each of these columns, one box needs to say 1, one box needs to say 2, and one box needs to say 3. So if you put a 1 here, a 2 here, and a 3 here, it means that show 1 is at 9 p.m., show 2 is at 11 p.m., show 3 is at 1 a.m. When you go to week 2, you need to do the same thing. Put a 1 in one box, a 2 in another box, and a 3 in another box. And you could change the order. For example, you could say during week 2, you could put 3, 1, and then a 2, meaning the third show is at 9 p.m., the second show at 11 p.m., and the first show at 1 a.m. So overall, what you need to do is, in this first table, go 1 column at a time, and in each column, put a 1 in one box and a 2 in the other box. So a 1 and a 2 in here, a 1 and a 2 in here, a 1 and a 2 in here. As long as each column has a 1 and a 2 inside the column. Here you can do whatever order you want. You could do 3, 1, 2, 2, 1, 3, 1, 2, 3, and so on. As long as in each column, one box has a 1, one box has a 2, one box has a 3 for the 3 shows. And just let me know if you have any questions.